guys, today's lesson is writing absolute value equations and inequalities given a graph. And this first part, this first sheet is going to then help us solve absolute value equations and inequalities word problems. Down below the title here, I have a little model to help us out writing these inequalities or these equations in absolute value form. Okay, so for number one, what I advise you guys to do is actually just start writing the absolute value of x minus what the middle and actual part here is. The middle part is actually helping us out with the graph, and when it says actual, that's going to help us out later on with the word problems. And the middle is the middle value in between the two dots that are going to be on the graph, noting two values that are solutions or maybe not solutions. So the middle is the value in between those. In this case, that would be 0. That is in the middle of the two solutions that we see in number 1. Remember, absolute value problems are going to have two values that are equidistant to one central value. In this case, it's 0. So we're going to have x minus 0, the absolute value. The next part we have to decide is whether we're going to use an inequality sign or an equal sign. Well, in number 1, there are two solid circles above -4 and 4. There are no further arrows or a line in between showing that there are any more solutions. Therefore, there are exactly two solutions for number 1. Are there exactly two solutions in inequalities or in absolute value equations? In this case, it's going to be an absolute value equation because, as in last lesson, you saw that when you solve an absolute value equation, you get two exact answers. The last part we're going to find is the distance or the range from the central value to the solutions. In this case, from the middle to the solutions would be 1, 2, 3, 4. So we would put 4. The last step here is just to simplify what we have. We wouldn't leave x minus 0. We would simplify the inside to get the absolute value of x is equal to 4. And this would be our absolute value equation for number 1. You could double check to see if it makes sense. If there are two solutions for our solution graph, meaning that the solution is 4 and -4, you could always just plug that in to make sure it is true for the equation that we made. So if x is 4, is the absolute value of 4 equal to 4? Yes, it is. And if x was -4, would the absolute value of -4 equal to 4? Yes, it is. So therefore, I know I'm correct. The next graph below is a little bit different because although we have two dots representing that -3 and 3 are solutions, what we also have is a line in between showing that all the numbers in between are also solutions. So what I advise you guys to do is just start writing your answer. We're going to write an absolute value, either equation or inequality. So far we have the absolute value of x minus the middle number. Again, that's the number in between the two dots that you have, noting the solutions. Again, that is going to be 0. It's in the middle. The next thing we're going to do is decide if it's an inequality or equation. Well, we know equations have two exact solutions, so it's not that. It's got to be one of the inequalities, a greater than sign or a less than sign. Remember, in absolute value inequalities, the sign shows you or tells you what compound inequality you're going to have. Now we're doing the opposite. What compound inequality would have two solutions with all the other solutions in between them? That would be an and compound inequality. Is it the greater than sign that we're going to use or the less than sign? The less than sign represents and compound inequalities. The next thing you need to ask yourself is, Is it just a less than sign, or is it a less than or equal to sign? Well, if it was a less than sign, these two circles would actually be open circles. They wouldn't be filled in. Since they are filled in, it's a less than or equal to sign. Lastly, we're going to find the distance from the middle to the outside, the most outermost solutions, and that would be 1, 2, 3. Just like problem number 1, we're then going to simplify that x minus 0 and get the absolute value of x is less than or equal to 3. In this case, we wrote an absolute value inequality, and we were determining these things just based on the way the graph looks. Number 1 was 2 solutions, so that must have been an equation. The solution graph for number 2 looks like an and compound inequality because the solutions are more than 2. It's -3, 3, and every number in between. That's an and compound inequality in which the less than sign represents. So as you guys could see, we are doing the opposite of last lesson. I'm going to jump down to number 4 here. And the first thing we're going to do is just start writing our answer. As you can see, number 4 is different from 1 and 2. So we have the absolute value of x minus, what is the value in between the two solid answers, or the two dots? That would be, so we go 2 to 1, -1 to 0. And what would be in the middle would actually be 1/2. So we got x minus 1/2, absolute value. In this case, we know it's not an equation because there's more than 2 exact solutions. There's actually a lot more. The solutions are 2 and everything greater than it, and -1 and everything less than that. We know that this is going to be an inequality. However, which one are we going to use? Are we going to use the greater than sign or the less than sign like we did with number 2? I'm saying these words weird to help you realize that the less than sign is for and compound inequalities, and the greater than sign is for or compound inequalities. This is an example of an or compound inequality because the solutions are outside 2 values. So we would have a greater than sign. The circles above the -1 and 2 are filled in, so I know it's greater than or equal to. If they were open, it would just be greater than. And then what is the distance from the central number to the outside values, or the first solutions? It would be 1/2 plus 1, so it would be 1.5. You could write it as 1.5 or 1.5. In this case, there's nothing to simplify inside the absolute values, so we would actually leave our answer like this. What I'd like you guys to do is try number 3 and 5. Pause the video, write your answer, and then play the video to see the answers and an explanation. Here are the answers for number 3 and number 5. Number 3 is similar to number 1, where there's 2 exact numbers. The middle number is going to be -1, so in your absolute value signs, you're going to have minus -1. And for your answer, you would simplify that, the absolute value of x plus 1. Since it's only 2 exact solutions, there's no arrows or lines in between. I know it's an equation similar to number 1. And the distance from the middle value to the solutions are 3. So we're left with the absolute value of x plus 1 equals to 3. This answer right here. And number 5 is similar to number 2, such that we have an and compound inequality graph because we have 2 values. They happen to not be solutions because they're open circles, but the solutions are in between those 2 values. We know that and compound inequalities, the solution graphs look like that. The middle number here in the middle of the 2 noted values with the circles is -2. So similar to 3, you would simplify x minus -2 to x plus 2. So we have the absolute value of x plus 2. It's not an equation because that would just have two solutions, like 1 and 3. This is similar to 2, that it is an inequality, specifically an and compound inequality. So we will use the less than sign. And since the circles are open, it's just a less than sign, not less than or equal to. And then our central value, since it was -2, the distance from the middle to the outside values would be 1, 2, 3. So our final answer would be the absolute value of x plus 2 is less than 3. We, again, are just following along with this model here that would help you decide what numbers go where. All right? This is going to help us now with our absolute value word problems. So the word problems we have here are not only going to ask us to solve a word problem and give us an answer that would make sense for the situation, but they're also going to ask us to write either an absolute value inequality or absolute value equation to represent the situation. The easy thing is they actually tell you which one they want you to write. So in this case, they want us to write an absolute value inequality. And they also then want us to answer what is the range of the number of the calories in the chicken entree. So the answer to this is actually really easy. A lot of you will just be able to do this in your head. However, coming up with the absolute value inequality or equation could be a little tricky. What we're going to do is essentially make these word problems the same type of problems we just did by first representing the situation on a number line. So this specific word problem is telling us that the menu at a restaurant states that the roasted chicken with vegetables entree typically contains 480 calories. Based on the size of the chicken, the actual number of calories in the entree could vary by as many as 40 calories. What that means is it could be 40 calories more than what it usually is, or 40 calories less than what it usually is. So let's represent this on a number line real quick and say that the chicken entree is usually 480 calories, but sometimes it could vary as many as 40 calories. That means it could be as much as 40 calories more if it's a bigger chicken, which would be 520 calories. Or if it's a smaller chicken entree, it would be 40 calories less than the usual, which would be 440 calories. They're asking here for the range of calories, the range of the number of calories in the chicken. So we already know we could answer the question that the range is anywhere from 440 calories to 520 calories, with any solution in between or any value in between being a solution. So it could be anywhere from 440 to 520. Now that we have this graph, we could very easily write the absolute value inequality that represents this. As you could see, since we have solutions in between two values, it's an and compound inequality, so we're going to use the less than sign. So just like the previous page, we're going to have the absolute value of x minus the middle value, or what the actual value of whatever they're talking about. In this case, it's calories. It's usually 480 calories. Is less than or equal to, and then the distance or the range. That's how much the middle number could vary by, and in this case, that would be 40. From 480 to 520, that would be 40. And from 480 to 440, that would also be 40. So here we have our inequality. We could also solve this inequality as we did with the previous lesson, solving absolute value inequalities, to make sure that we do get our answer, the range 440 to 520, if you wish. If not, you would be done. So we just represented the situation with an absolute value inequality, and our answer would be in words. The calories could be anywhere from 440 to 520. Now in this problem, they asked for a range of numbers. In number 2 here, they're actually only asking for the maximum and minimum number. In this case, they're talking about seeds in a package, okay? They very specifically, however, ask you to write an absolute value equation, which makes sense because absolute value equations have exactly 2 answers. In this case, those 2 answers would represent the maximum number of seeds and the minimum number of seeds. So let's read from the top. The average number of seeds in a package of cucumber is 25 seeds. The number of seeds in the package can vary by 3. So usually there's 25 seeds. However, there's sometimes 3 more than that or anywhere from 3 less than that. So let's represent this again on our number line. Usually there is 25 seeds, and there could be varied by 3. So there could be 3 more than that, which would give us 28, or 3 less than that, which would give us 22. Again, in this case, they're asking us the minimum and maximum, which is just 2 answers. So we would answer that the minimum number of seeds is 22 seeds, and the maximum number of seeds would be 28. There you go. We already answered the problem. However, part of the problem and the points that you're going to receive is writing an absolute value equation to represent this. So we have the absolute value of x minus the actual number of seeds that are usually in the package, or the central or middle value, which is 25, is equal to the range, or how much that middle number could vary by, which would be 3. So here is our equation to represent the situation, and our answer would be the maximum is 28 seeds and the minimum is 22 seeds. Again, you could always double check to see if you're correct by solving the equation or inequality you make. For example, if I wanted to check to see if this equation would give us the answer 22 and 28, we could simply just solve. X minus 25 is equal to 3. And x minus 25 equals negative 3. Let's find the values of x that would make this true by adding 25 on each side of both of the equations to give us x equals 28. That was one of our answers. And x equals 22. That was the other one of our answers. Therefore, the equation makes sense. What I'm going to advise you guys to do is try number 4 and number 5. If you wish to practice one more problem, you could also try number 3. Number 3 and number 4 are very similar. That's why I'm skipping and going to 5. So try number 4 and 5. If you want an extra practice, try number 3. For those of you who would like a little bit of a challenge, you could try number 6. And I'll make sure I show you all of the answers. Pause the video and try out the word problems. Here are our answers for 3 through 6. 3 and 4, again, were very similar. So if you tried them both, they were both and compound inequalities and asked for a range. Here are the absolute value inequalities you should have made for the 2. And the solutions you would write in either your notebook or a quiz or a test. Those are the answers, okay? And number 5 only asked for the maximum and minimum, making that 2 answers, or an absolute value equation. Remember, it also just asked you for an absolute value equation, so that was easy to know it was going to be an equal sign. And then the maximum that Victor might have made is 8150, and the minimum is 6850. If you did try the challenge and you had questions about that, please let me know. If you had questions about any of the word problems, please let me know, and I'll talk to you guys soon.